Hey guys, Mr. B here, and in this video we're going to be going through the practice problems in quizzes for chapter 12.2. I have quizzes open here. I'm not going to put the timer on just because I want to make sure I can take my time to explain as I go through each problem. I'm going to be going through them in Word. I have them already copy pasted here just to save me some time. I don't have to type them out. But either way, these are the same problems that are on quizzes. So here we go. Let's join in. I don't need to watch a video because I have already seen it. I did it live. So first question says, how many moles of oxygen are required to react completely with 14.8 moles of aluminum? Okay, so I have this set up right here again. I've copy pasted this problem already into a Word document where I can do some typing and I can show you how to do this. That is not what we were looking for. My bad. There we go. Okay, so the question is asking how many moles of oxygen are required to completely react with 14.8 moles of aluminum. So we're starting with 14.8 moles of aluminum. Make our font a little bit bigger here. And we are going to get into moles of O2. Okay, moles of O2. So this should be pretty much just a one-step problem. Remember that in order to go from moles of one material to moles of another material, we need to use the mole ratios in the equation. So for aluminum to oxygen, it is a 4:3 ratio. Okay, so if I set up a conversion factor, basically every 3 moles of O2 for 4 moles of aluminum, okay, like this. And again, I'm doing it so that my moles of aluminum, which I'm starting with, is going to cancel out with moles of aluminum in the conversion factor, and I'll be left with moles of O2 as my answer. So I'm basically going to take 14.8, and I'm going to multiply that by 3, and then divide that by 4, and we will get an answer of 11.1 moles of oxygen. And it does say around to 3 sig figs. We already have 3 sig figs, so let's go put this in and hit submit. There we go. Voila. All right. How many moles of Al2O3 are formed when 0.78 moles of oxygen reacts with aluminum? Okay, so now we have the second problem, again, which I have already copy pasted here. So how many moles of Al2O3 are formed when 0.78 moles of O2 react? Okay, so again, let's set up our math. So 0.78 moles of O2 is what we have to begin with. And we are getting into moles of Al2O3. Okay, so to go from, again, moles of one material to moles of another material, we just need to use the mole ratios in the problem. And in this case, it's a 3:2 ratio. Okay, so for every 3 moles of oxygen, we'll make 2 moles of Al2O3. So again, since I'm starting with moles of O2, I want to put the 2 moles of Al2O3 on the top of my fraction and the 3 moles of O2 on the bottom of my fraction, okay, like this. That way my moles of O2 will cancel, and I'll be left in moles of Al2O3. So I'm going to take 0.78 times 2, divide by 3, and I get 0.52 moles of Al2O3. It does say it around to 2 sig figs, which we already have. So let's go put that in. So 0.52, hit submit. All right, we know what we're doing. All right, acetylene gas is produced by adding water to calcium carbide. All right, so they have this reaction. How many grams of acetylene are produced by adding water to 5 grams of CaC2? Okay, so let's again open up the problem here in our Word document. Okay, so they've got all this stuff here at the beginning, blah, blah, blah. Okay, but here's our reaction. So the question is how many grams of acetylene? Okay, now acetylene is this C2H2 material, okay? So how many grams of acetylene are produced by adding water to 5 grams of CaC2, which is calcium carbide? So let's, again, change our font, or change our size. So we're starting with 5 grams of CaC2. And our final answer is going to be grams of acetylene, which is C2H2. Okay, C2H2. So that's this material here. So we're going from grams of this material to grams of this material. Okay, that's what we're doing. All right, so step 1 is convert grams of CaC2 into moles of CaC2. Okay, step 1 is always get into moles if we're not in moles already, which we're not in this case. So we got to convert into moles. Now to do that, we're going to need to know molar mass for this CaC2 material. Okay, now on my periodic table, which again I have right here, calcium has a molar mass of about 40. Okay, I'm just going to round to whole numbers here. So 40 for the calcium, plus carbon is 12, and there are 2 of them. So total, we get a molar mass of 64 grams per mole. So I'm starting with grams of CaC2, which means I'm going to have 1 mole of CaC2 on the top over 64 grams on the bottom. Okay, and I'm doing it this way so that way my grams of CaC2 cancel with each other, and I am going to be left then in moles of CaC2, okay, which is again what this first step is. We're trying to get into moles. So 5.00 divided by 64, I get 0.078125. I'm just going to keep the whole thing. We'll round properly at the very end, okay? All right, so the next step from here then is going to be to convert moles of CaC2 into grams of don't listen to me. Convert moles of CaC2 into moles of C2H2. Okay, so we're going from, so first we went from grams of CaC2 into moles of CaC2. Then we're going to go from moles of that material we just got into moles of the other material that they want, which is this C2H2, okay, acetylene. So to do that, we need to know the mole ratios. Now in here, it looks like it is a 1-to-1 ratio. So basically the amount of moles of calcium carbide that we have is the same amount of moles of acetylene, which pretty much means this answer that we had in step 1 is going to be exactly the same for the acetylene. Okay, so for every 1 mole of calcium carbide, it's 1 mole of acetylene, which means they're the same. Okay, we literally don't need to do any math work for this. We can just go, oh, yep, same stuff. Okay, step 3 then is we are going to convert moles of C2H2 into grams of C2H2. And we're converting into grams because the question is asking for how many grams of acetylene are produced. And right now we have moles of acetylene. So we're going to take the moles here that we have and just convert those into grams. And to do that, we need to know molar mass. So molar mass for C2H2, again, I have my periodic table here. Carbon is 12, times that by 2. Hydrogen is 1, times that by 2. Add those together, we get a molar mass of 26 grams per mole. Since I'm starting in moles of C2H2, the 26 grams of C2H2 will be on the top, and the 1 mole of C2H2 will be on the bottom. That way my moles of acetylene cancel, and I'm going to be left in grams of acetylene. So we're going to take our 0.078125 and just times that by 26. And we get 2.03. And I think it does say to round to round to the nearest whole number. Oh, okay, so round to the nearest whole number. So we have 2.03, whatever. We're just going to round to 2 grams of C2H2. Okay, so that is our answer. Let's go put that in quizzes as a 2. There we go, we got it. Okay, next problem. Calculate the mass of oxygen produced from the decomposition of 75 grams of potassium chlorate, rounded the nearest whole number. Okay, so here's our problem. Again, I have it already copy-pasted here on our Word doc. So they want us to find the mass of oxygen produced from 75 grams of calcium or potassium chlorate. So we have 75.0 grams of potassium chlorate, which in the problem is the KClO3, and we're going to get that into grams of O2. Okay, grams of O2. All right. Excuse me. So step 1, convert grams of KClO3 into moles of KClO3. Step 2, convert moles of KClO3 into moles of O2. And then step 3, convert moles of O2 into grams of O2. Right, those are 3 steps. All right, so starting with the first one. There you go. We are starting with 75 grams of KClO3. To convert that into moles, we need to know molar mass. So on a periodic table, we're going to take the mass of potassium, 1 potassium, which is 39, plus the mass of 1 chlorine, which is 35.45, plus the mass of 3 oxygens, which are 16 apiece, so multiply that by 3. And we add all that together, and I get 122.45 grams per mole. Since I'm starting with grams of KClO3, I want the 1 mole of KClO3 to be on the top, and the 122.45 grams of KClO3 to be on the bottom, okay, like this. That way my grams cancel out with each other, so grams cancel with grams. And we're basically going to take 75, divide by 122.45. I get 0.6124949. Again, I'm going to round everything at the end. So we'll go KClO3. Okay, so there's our moles of that one. Okay. Next step here is we're going to take that number of moles that we just got and go from moles of that to moles of oxygen. So we're going to end up in moles of O2. And looking at this, it is a 2 to 3 ratio. So for every 2 moles of KClO3, we are going to make 3 moles of O2. Okay, so for every 2 moles of KClO3, we're going to make 3 moles of O2. And again, you'll see that I'm setting up my conversions so that moles of KClO3, which is what we're starting with, is on the bottom of the fraction, so it cancels. So I'm going to take our first answer, our number to begin with, and we're going to multiply that by 3, divide it by 2, and I get 0.91874.234. Again, I'm going to round at the end, okay, appropriately. All right, so there's our moles of O2, and then the last part is we are going to convert moles of O2 into grams of O2. And to do that, we will need the molar mass of O2, which oxygen has a molar mass of 16. Times that by 2, that's 32 grams per mole. So we'll have 32 grams of O2 on the top, 1 mole of O2 on the bottom. And we're basically going to take that 0.91874.234, so that first number, multiply that by 32. And it does say round to the nearest whole number, so we're going to round this to 20. My calculator tells me 29.399 something or other. We're just going to round this to 29 grams of O2. Okay, 29 grams. So 29. All right, we're on a roll. Here we go. How many molecules of oxygen are produced from the decomposition of 6.54 grams of potassium chlorate? Okay, so this is basically like the same problem that we just did. However, the challenging or tricky part now to this one is they want us to end in molecules of O2 instead of grams of O2. Okay, so this last step that we did before where we converted moles of O2 into grams, that's going to convert from moles of O2 into molecules. Okay, so it's going to be a different conversion factor. But otherwise, pretty much this whole part at the beginning in this previous one is exactly the same. So we are starting with, we're starting with 6.54 grams of KClO3, and we are going to get into molecules of O2. Okay, so step 1, convert grams of KClO3 into moles. Okay, that's always the first step, is get into moles if you're not in moles. Step 2, convert moles of KClO3 into moles of O2. And then step 3 is now we're going to convert moles of O2 into molecules of O2. Okay, so basically step 1 and 2 are exactly the same. Step 3 has a little bit of a change to it. So, all right, here we go. So we're going to start with 6.54 grams of KClO3. We got to convert this into moles of KClO3, which we'll need molar mass. We actually already found it in the previous problem, so I'm just going to scroll up. So 122.45 grams per mole. So that's our conversion. So we're just going to copy paste to make our lives easier. So copy paste, and it's going to copy paste the exact same way because we're starting with grams of KClO3. So those will cancel like that. This is the font a little bit too big, 14. There we go. Okay, so those will cancel out. But wait, so we're going to take 6.54. Divide by 122.45, and I get 0.0534095. Again, I'll round at the end. All right, so now we are going to take that number. We're going to go from moles of KClO3 to moles of O2, and it again is a 2 to 3 ratio. So we're going to multiply this by 3 moles of O2 over 2 moles of KClO3. Okay, again, hopefully you're noticing that I'm canceling out my moles of KClO3 by putting my conversion factor this way. So let's take that number that we had to begin with. We're going to times that by 3, divide that by 2. We get 0.0801143 moles of O2. Again, I'm going to round at the end. And then lastly, okay, this is the last step that is different from the previous one, is we're going to go from moles of O2 into molecules of O2. Okay, so now to do this conversion, we need to use Avogadro's number, which, again, we may not remember from chapter 10, but that is 6.02 times 10 to the 23rd molecules per 1 mole. So to set this up properly, we'll have 6.02 times 10 to the 23rd molecules of O2 over 1 mole of O2. Okay? And again, you'll see that my moles of O2, which is what I'm beginning with, are on the bottom of my conversion factor so that they cancel. And we're basically just going to take our number to begin with. We're going to multiply that by 6.02 times 10 to the 23rd. And I get 4.8228 times 10 to the 22nd molecules. And it does say round to 3 significant figures. So 4.82 times 10 to the 22nd molecules of O2 is what we get. And in our answer here, it already has the times 10 to the 22. So basically 4.82 is all we should have to type in. Hit submit. There we go. All right. Phosphorus and hydrogen can be combined to form phosphine, Ph3. How many liters of phosphine are formed when 0.42 liters of hydrogen reacts with phosphorus? Okay, so let's go to our Word docs. Again, I have this already copy-pasted. All right. So in this problem, we are now dealing with liters. Okay, so this problem is just like the previous one, where we're just dealing with a different unit. Instead of grams, we're dealing with liters. Okay, but we're basically taking 0.42 liters of hydrogen, which is H2, and they want to know how many liters of phosphine are formed. So they want to know liters of pH3. Okay, that's phosphine in this problem. All right, hopefully we're starting to get down the steps here, but step 1, what is it? You got it right. Nice job. It is convert liters of H2 into moles of H2. Okay, that is step 1. All right. Step 2, what do we do now? Moles of H2 into? You guys are so smart. It is going to be converting moles of H2 into moles of pH3. I knew you guys knew this. All right, here we go. And then lastly, step 3 is going to be what in this problem? You are correct. You are correct. We are going to be taking our moles of pH3. Okay, so convert moles of pH3 into liters of pH3. Okay, because that's what they want us to end in, is liters. All right, so let's get to it on this problem. So we are starting with 0.42 liters of H2. And we are going to convert that into moles of H2. All right, now to do this, we are going to need to use molar volume, which is 22.4 liters per 1 mole. Okay, again, that is from chapter 10. You may not remember that. But our conversion factor now is going to be 1 mole of H2 on the top over 22.4 liters of H2 on the bottom. Okay, like this. That way our liters of H2 cancel out, and we will get into moles of H2. All right, so we're going to take 0.42 divide by 22.4. And again, we'll do all of our rounding at the end. Okay, so we get 0.01875 moles of H2. All right, so there is our moles of H2. Then this next step is to convert our moles of H2 into moles of pH3. To do that, we will need to, of course, use our balanced chemical equation. So it looks like for every 6 moles of H2, we make 4 moles of pH3. So it's a 6-to-4 ratio or a 3-to-2 ratio, but either way, we're going to set it up like this. So since we're starting with moles of H2, we're going to have 4 moles of pH3 on the top over the 6 moles of H2 on the bottom. Okay, again, I am doing this so that way my moles of H2 cancel out, and I get into moles of pH3. So we're going to take our number 0.01875, times that by 4, divide that by 6, and I get 0.0125 moles of pH3. And then lastly, we are going to convert that into liters of pH3, which is pretty much going to be the exact same conversion as step 1 because we are converting from liters into moles. But now we're going from moles to liters. So the conversion factor is going to be the same conversion factor, okay? But the difference now is we need to flip it around because we are now going to be ending in liters of pH3 and we are starting in moles. So we're going to have 22.4 liters of pH3 on the top and the 1 mole of pH3 on the bottom. That way our moles of pH3 cancel out and we'll be left in liters of pH3. So take our 0.0125 and times that by 22.4, and we get 0.28 liters. And it does say round to 2 significant figures, which is what we have right there. So 0.28 should be our answer. All right, nice job, guys. Good work. All right. 2 more. Calculate the volume of sulfur dioxide produced when 27.9 milliliters of O2 reacts with carbon disulfide. Here's our reaction. Okay, so let's go and look at our problem. Again, I have it copy-pasted here already. So it says, calculate the volume of sulfur dioxide produced when 27.9 milliliters of O2 reacts with carbon disulfide. So we have 27.9 milliliters of O2, and this is going to be reacting, and they want us to find the volume of sulfur dioxide. So that's going to be liters of SO2. Okay, SO2 is sulfur dioxide. All right, now there was a problem like this in the notes where because we are starting in milliliters, we need to convert our milliliters into liters first before we can get to moles. Okay, so step 1 is going to be convert milliliters of O2 into liters of O2. And the reason we need to do that is because we need to get our volume of oxygen into moles, but we can't do that unless it's in liters because the only conversion factor that we have that deals with liters to moles is molar volume, and that's 22.4 liters per mole, not 22.4 milliliters per mole. Okay, so step 1 is convert milliliters into liters. Step 2 is convert liters of O2 into moles of O2. Then from here, we're going to go from moles of O2 to moles of SO2. So convert moles of O2 into moles of SO2. Then step 4, it does say calculate the volume of sulfur dioxide. And let's just make sure. Okay, so they do want volume in liters, which means that our last step is going to be convert moles of SO2 into liters of SO2. Okay, so it's going to be kind of like 4 steps. All right, so step one. Oh, there we go. Step one. We're starting with 27.9 milliliters of O2. We got to convert this into liters of O2. So milli means 1,000 times smaller. So there are 1,000 milliliters in 1 liter. That's our conversion factor. Okay, so 1 liter of O2 on the top over 1,000 milliliters of O2 on the bottom. That way our milliliters of O2 cancel out with each other. I don't know the hotkey for the strike through, unfortunately, in Word. But okay, so 27.9, divide that by 1,000. Okay, so we get 0.0279. Again, we'll do all the rounding at the end. So now that we have liters, now we can convert our liters into moles using molar volume. So we're going to get into moles of O2. And that means we need to use the 22.4 liters per mole. So since we're starting in liters of O2, we're going to have 1 mole of O2 on the top and the 22.4 liters of O2 on the bottom. That way our liters cancel out with each other. Okay, so those will cancel and those will cancel. So we're going to take 0.0279, divide by 22.4. We're getting some small numbers here. So 0.001245554. Again, I'll do all the rounding at the end. All right, so there's our moles of oxygen. Now we are going to go from moles of oxygen into moles of SO2. And the ratio between the two is 3 moles of O2 for every 2 moles of SO2. So it's a 3-to-2 ratio. So we're going to have it set up for 2 moles of SO2 on the top and 3 moles of O2 on the bottom, like this. Just to double check. 3, 2. Okay, I'm just making sure that we have the right numbers. Okay, so that will cancel out with this. So we're going to take our beginning number, this, so we're going to times it by 2, then divide it by 3. Again, even smaller numbers, 0.000833036. And then lastly, we're going to take that and we're going to convert this from, we're going to convert, sorry, I'm getting confused. We're going to convert from moles back into liters. And to do that, we will need to use the molar volume conversion, which is what we used right here in step 2. But now we just need to flip it. So since we're starting with moles of O2, 22.4 liters of SO2, sorry, SO2 is what I meant. 22.4 liters of SO2 on the top, 1 mole of SO2 on the bottom. That way moles of SO2 cancel out, and we will then be finally in liters. So take that times 22.4, and I get 0.0186. And it does say to round to 3 significant figures, which is what we have right there. So I believe that is our final answer. 0.0186. 0.0186. Let's hit submit. All right, we got there. All right, last problem. Calculate the number of liters of oxygen gas needed to produce 15 liters of dinitrogen trioxide. Assume all gases are at the same conditions of temperature and pressure. All right, so let's go to our document here. Here's our last problem. So calculate the number of liters of oxygen gas needed to produce 15 liters of dinitrogen trioxide. All right, so the measurement they're giving us to begin with is 15.0 liters of dinitrogen trioxide. So that's the N2O3. And we are going to end in liters of O2. Okay, so we're going from liters of N2O3 to liters of O2. All right, so step 1, what is it? You got it. We are going to be converting liters of N2O3 into moles of N2O3. Okay, step 1, always convert to moles. If you're not in moles already. Okay, if you're already in moles, then you don't need to do that part. All right, step 2, once we've converted into moles of N2O3, what's our next step? You are also correct again. We're going to convert our moles of N2O3 into moles of O2. Okay? Then lastly, if we need to have liters of O2, what is our third and final step? Man, you guys are so smart. We are going to convert moles of O2 into liters of O2. So So moles of O2 into liters of O2. And there we go. And that would be all of our steps. All right. So here we go. Let's do it. Starting off, we have 15.0 liters of N2O3. Since we are going from liters of N2O3 into moles of N2O3, we're going from liters to moles. Conversion factor we will need is going to be molar volume. So that is the 22.4 liters per mole. So we're going to have 1 mole of N2O3 on the top over the 22.4 liters of N2O3 on the bottom. N2O3 on the bottom. There we go. Because we are starting with liters of N2O3, and we want that to cancel with our liters of N2O3 in our conversion factor. So we're going to take 15.0, divide by 22.4. Again, we'll do all rounding at the end. So we get 0.66964286. There's moles of N2O3. Then from here, we're going to convert moles of N2O3 into moles of O2. To do that, we'll need to look at the mole ratios in the reaction. So it looks like for every 2 moles of N2O3 that we make, we are going to need 3 moles of O2. So it's a 2 to 3 ratio. So 3 moles of O2 on the top and 2 moles of N2O3 on the bottom. Because again, we want our moles of N2O3 to cancel because that's what we are starting with right there. So we want that to cancel out with our conversion factor like so. So take our answer from the previous part, times that by 3, divide that by 2, and I get 1.00446429. And then lastly, we are going to convert that back into liters. So to do that, we need to use our molar volume conversion again, like we did in step 1. But now, since we're starting with moles of O2, the 22.4 liters of O2 will be on the top, and the 1 mole of O2 will be on the bottom. Okay, like that. That way, again, our moles of O2 will cancel out with each other. Oh, wrong one. There we go. Moles of O2 will cancel. So we're going to take our 1.00446429 times 22.4 equals, and I get 22.5 liters of O2, and it does say to round your answer to 3 significant figures, which is what we have right there. That should be our final answer. So here we go. 22.5. Did we get it? There we go. All right, guys. So that is all of the practice problems for that section of notes. I know that took a while, but I really wanted to make sure I went over each one and explained it. So hopefully that helped you and you're feeling a lot more comfortable and confident with this stuff. But again, as always, if you have any questions or need any additional help, please feel free to reach out to me so that I can help you. All right, that's it for this one. See you in the next one. Bye.